Hello, college prep class. We're going to continue talking about circles. This is, let's see what, chapter 6, section 3. We left off at tangents and radius, radii, which is the plural for radius. The radius is a line segment that goes from the center of a circle to the circumference of a circle. And a tangent line, on the other hand, is a line, straight up line, that skims by a circle, touching it at one point. Okay, so a line that just goes right by a circle and touches the circle at one point. So the circle comes in, touches the line, and goes out. A tangent line will always be perpendicular to radius. So at whatever point the tangent line hits the circle, there's a radius that goes from that point to the center, and it'll always be a 90-degree angle that they meet. That seems to come up a little bit in the book and in the SATs. It comes up, I don't want to say a lot, but it will come up. It seems, no guarantee, but it might. So a radius drawn to the point of contact of a tangent forms a right angle with the tangent at that point. Okay, so if you draw, that's saying if you have a tangent line and you draw the radius from this point that the tangent hits to the center, this will be 90 degrees. Okay. So we have a situation here where we have two tangents coming in, and we know they're tangents just from the picture because of this 90-degree angle. Well, maybe not just that. That 90-degree angle is a good indication, though, that they're tangents. So if two tangents are drawn to a circle from the same exterior point, then the following relationships are always true. So we have a point outside the circle, and it's drawing, and there's two lines that are drawn so that they're tangents with the circle. So hopefully that makes sense. What's going on there? The tangents will have the same length from that point that's external to the point of where they're a tangent. So these two line segments will be, this one right here, PB, will be equal, that length will be equal to PA, or AP and BP. Okay. Opposite angles of the quadrilateral that have formed are supplementary. So if you then take the radius here, the radii, and draw them from the center to these 2 points, you create a quadrilateral. See this quadrilateral here? Okay. It's saying that these two angle measures. Oh, there's a typo. Let me fix that. Opposite angles of the quadrilateral that is formed are supplementary. Okay, so they're not, this angle and this angle are both 90, right? Remember, quadrilaterals add up to 360. So this all four of these angles must add up to 360. Well, we know because of the definition of tangents and how tangents work that these two are 90. Okay, well that adds up to 180. That'll leave 180 degrees for this angle here and this angle here. So between these two angles you have 180 degrees. When two angles add up to 180, we call that supplementary angles. So this is saying opposite angles in the quadrilateral are supplementary, because these two would be supplementary because 90 and 90 add up to 180. That makes them supplementary. And that leaves 180 to be split between this angle and this angle. So that's one, that's also considered supplementary. So essentially, if you would know this measure here, this angle measure here, you can find this angle measure, because all four of these have to add up to 360. We know we can subtract 180, so that between these two there's 180 left. So you can take 180 minus whatever measure this is and find this angle measure. It goes both ways, though, too. If you would happen to know this one, you could find this one by taking 180 minus it. The segment drawn from point P to the center of the circle divides the quadrilateral into two congruent right triangles. So that is saying a segment drawn from this point here to the center of the circle. And I think I might be able to do this. Let's try this. So a segment drawn from here to here divides this quadrilateral into two congruent triangles. We know that this side here is equal to this side here. Well, the radius isn't going to change measure. That's the definition of the radius, is the length from the center to any point along the circle. So these are going to actually be equal as well. Okay, you're going to take this angle right here is right angle, this right angle right here is right angle. So you're going to take this measure here and you're going to divide it in two by doing this. So whatever's here will be here. So you can see that, and then same here, that this will be divided into two. So you're taking this quadrilateral, you're dividing it, and you're actually making it into two congruent triangles, which means all the side, like every side has a corresponding side on the other triangle that's equal. Every angle has a corresponding angle on the other triangle that's equal. Okay, so you're taking this quadrilateral that's formed by this one point here. All of this happened by just picking a point outside the side of the circle and drawing tangents to it, and we're noticing all the stuff that's happening. Well, you're taking this quadrilateral that forms, and you're able to divide it equally in half and get two congruent triangles. So, you ready for an example of this stuff? All right, in the figure below, line segment PA and PB are tangent to circle O. That's the center of the circle. Points A and B, respectively, at points A and B. Okay, sorry. Tangent to circle O at points A and B, respectively. And the measure of APB is 60 degrees, so this entire measure here. Segment OP is drawn, okay? You see that dotted segment? If OP is 4 over pi, this length of this is 4 over pi, what is the length of minor arc AB? They want to know the length of this here. Woo! How do we find that from all this information? Well, I'll go through this. First of all, if they're tangent, we know that this is a right angle here, and we know that this is a right angle here. That's just a fact by the definition of tangent. We know this is 60, and remember, if this is 60, then that tells us what this is, because these two have to add up to 180. So then this would be 120. Okay. So so I am deducing from this information that 120, and then I had to divide that up into two 60s. Okay. So I said that this was 120. Well, if we split that with that dash line, then each part is 60 degrees. This 60 gets cut in half and is 30/30. We know that this right here is 14 over pi. They gave that to us. So this is pretty much drawn out what I was just saying verbally. We see here that we have a 30, 60, 90 triangle. That's very useful. What we need to find, just in case you're wondering, what am I going for here? Well, if they want us to know, or want us to find what the minor arc length is, AB, from here to here along this curve, then we need two things. If we remember the formulas for minor arc, finding arc length, I could actually probably scroll up here. Let's go up to arc length. Here, that's the area of the circle. Similar though, arc length is, so we need if we go down to this part right here, we need the measure of the interior angle, and we need the radius. If we have those two things, then we can find the measure of this arc length. And we do already have the measure of the interior angle. That would be 120. We found that. What we need is the radius. We are looking for the radius. So let's go back down. Gotta be careful. I don't want to go too far, too fast, and spoil anything. So we have the 120. We were looking for the length of AO or BO, whichever, OB, OA. So, but we've determined there's a 30, 60, 90 right triangle here. 30, 60, 90 triangle. And that is a special right triangle. Remember, the special right triangle, the unique, what makes it special is that the hypotenuse, this is the right angle here, so this would be the hypotenuse. I'm looking at the top one right now, the top triangle. So the hypotenuse and the shorter leg, we have a longer leg and a shorter leg. Well, they are related, and it's the shorter leg that we're looking for. We're not interested in the longer leg. At least that's not anything that's going to help us accomplish what we need is this length here. Well, we could find that and then use Pythagorean theorem, but since we don't have that, there's no reason to use Pythagorean theorem when we can just jump to what this measure is right here. And the special, how they're related is that in special right triangle 30, 60, 90, the hypotenuse is always double the shorter leg, the length of the shorter leg. Or the length of the shorter leg is half the length of the hypotenuse. So OP is going to be double OA, or OA is going to be half OP. And this is R. Okay, this is our radius. So I'm replacing OA with R. I'm replacing OP with what we know. And I already explained that OA is going to be half OP. So 1/2 times 14 over pi. This 2 and 14 simplify to 7 over pi. So we have a radius of 7 over pi. And now I'm going to go to that arc length formula that I was just showing. I scrolled up to show you. And we now know what n is. It's 120. We now know what r is, 7 over pi. Fill in. So 120 over 360 is 1/3. And then we can do some simplification here. Fortunately, these pi's cancel out. That makes it nice. So pi over pi, that cancels out. We have 2 times 7, which is 14. Our answer is 14 over 3. Good stuff. So let's do another example here. In the figure below, the radius of each circle is 1. So telling us that the radius of each circle is 1. If circles O and P touch the sides of the rectangle, A, B, C, D, that's just making it clear that each of these circles come up and touch it at one point, even though sometimes, like graphically, maybe it's my scanning, maybe it's the print job, it might not. There might be a little bit of question about that. Well, they're making it clear in here. That's why we can't just go by what the figure says. We can go by what numbers are listed on the figure, but we can't look at a figure and assume things. But they're telling us that touches. There's no space in between the circle and the side of the rectangle. There's exactly one point there. So circles O and P touch the sides at the letters only. That means these are all tangents. This is a tangent line. This is tangent, tangent. What is the area of the shaded region? Now, this is very common in SATs, area of shaded region. What you need to do in a case like this is we have the larger figure, whatever the larger figure is, we want to find that area and we want to subtract whatever's inside of it. If the entire rectangle is shaded, well, then that would be easy. We'd do length times height. But what's happening is we're taking the length times height of the rectangle and we're going to subtract these regions out. So we want the area of the circles, we want the area of the rectangle, and we want to subtract the area of the rectangle minus the area of the circles will give us the shaded region. It's a very common problem that you'll get in the SATs. I'm going to label some stuff here. So if the radius is 1, so that means from going from O to K is the length 1. They said that in the problem. Each circle has a radius 1. Also going from O to E is 1. O to J is 1. There's no point in the middle, so I can't. But if there was, you could go this way too and get 1. So it's 1 every direction, which means that this rectangle has a height of 1 plus 1, which is 2. This rectangle also has a width or a base of 1 plus 1 plus 1 plus 1, which is 4. So finding the area of the rectangle, that's just a little figure, is base times height, which is 4 times 2, which is 8. So finding the area of the rectangle is 8. Finding the area of the circle shouldn't be that too difficult either. The area of one circle, that's what this is, it's a little circle figure, is pi r squared, and our radius is 1, so it's pi times 1 squared, pi times 1, which is pi. Okay, so if I find the area of one circle, then to find the area of the shaded region, what I want is area is equal to rectangle minus 2 times circle, because there's 2 circles in this area. And I'm going to fill in what I know. And 2 pi is approximately 6.283. So ultimately the decimal answer, so the exact answer will be 8 minus 2 pi. The decimal answer would be 1.717. Now if this was a multiple choice, and it depends on how they had wrote the answer which one that you would look at, look for, or if it's a free response, and you'd only have to put 1.71 because you only have space for 4 characters. So it would be 1.72. 1.71 would also work because they accept it either way, of whether you round up or truncate, or unless they would say something like only to 1 decimal place, then it would be 1.7. I think you get the idea. All right, let's do one more example. This is a multiple choice. In the figure below, PQ, line segment PQ is the diameter of circle O. They're also letting us know that AB, PQ, and CD are all parallel. That's what that says. They're also letting us know that AB is congruent to CD, so these two are the same measure, the same length. Okay. The length of chord AB, remember chord is a line segment that goes through a circle at 2 points. Passes through. The length of chord AB is 3/4 the length of the diameter. So if this diameter here was 1, this would be 3/4. If this was 12, this would be 9, because 9 is 3/4 of 12. Okay. If R represents the radius length of circle O, so that would be like from here to here. Okay. What is the distance between chords AB and CD? So they're looking for the distance from this chord down to this chord. So like a line that would go like this. I think I have a picture here, don't I? Yeah. So well, let me just draw this because it looks like, let me pick the right one. They're looking for a distance like that red line, and it would be, what they would be looking for is a right angle to a right angle. So this would be a right angle here. Let me draw that actually with a pen. So that would be a right angle, and this would be a right angle. That's what they're looking for. And it's multiple choice, so they give us some options. Again, always use elimination. If you can eliminate some of the options, that works. Remember that the diameter is twice the radius. These are all in terms of R, so when we're going to go through this, we don't have a value for R, unfortunately. So we're not going to get a final answer that is R. We're going to have to do everything in terms of R. And so that's what I'm going to do. Starting with noting that the diameter, the whole length across, is double the length of R. But AB is 3/4 the length of the diameter, according to the statement right there. So that means AB is 3/4 times 2R, which is this 4 and that 2 simplify to just over 2. So the length of AB is 3/2 the length of the radius. Okay, now here's where something happens that we're going to, that might be a little bit trickier to explain. If I, like what I did here, if this length is a right angle, I could also, it would be the same here with right angles and all. The same length would, let me just erase these and then let me start over and say this a little more clearly, hopefully. Okay, so if the distance from AB to CD is the right angle, a line segment that meets those both at right angles, that's the distance we're looking for. It doesn't matter where this line segment is, it's going to be the same distance anywhere along this. Because AB and CD are parallel, that distance doesn't change. So I'm going to put this so it goes straight through the center of the circle. Okay. Do you see that? This actually will create and I have a sketch below that's a little rough, but hopefully it'll actually create a triangle. It'll create a few triangles, so you could go in this direction, this direction, this direction, but you really only need to go in one direction. The purpose of this this triangle that I just drew and why this is helpful is, well, if this is by definition of an origin, this creates a sorry, this line that I just drew here is going to cut AB in half if it goes through I said origin, center of the circle. Okay, so this distance from this line, if it's going through the center of the circle, it's cutting this segment in half. It's going to cut this segment in half. It's going to cut all the segments in half. It's going through here at a right angle. So if we know that if we have a measurement for AB, we now know that from A to this point here is half of that. Okay. We know that AO, what this line right here is R. Okay. So this length right here is R. Actually, maybe I should type this stuff in here. Well, I think the picture below might help. We know that this is R. So what we're looking for is what this length is from O to this point here, given this measure, and knowing the ability for us to do the Pythagorean theorem. Okay. So here's my rough sketch that I had mentioned. AO is R. We want to know what X is, and AB was 3. AB was 3 halves times R. And we're going to cut that in half. So half of that would be 1 half times 3 halves, which would be 3/4 R. So we have a right triangle that we know this measure here is 3/4 R. We know this is R, and we want to find this measure here. Because once we find this measure, let me just go back. Once we know what this is, we can just double that to get this. And then we have our answer. Okay, so once we know what this measure is right here, once we know what this measure is right here, let me tell. That's not the right font, but you get the idea. I mean, it's a font, but it's not the same font up there. Once we know what this measure is here, that will give us what the ability to double that and find the answer we're looking for. Hopefully that's making sense. It's a little bit more of a complicated problem, but with a video like this, you can rewatch it. If it's a right triangle, then we know we can use Pythagorean theorem. We have the measure of the hypotenuse, and we have one leg, and we were looking for the other leg. So I'm plugging in for one leg plus our unknown that we're looking for and the hypotenuse. And one of the tricky things about a problem like this is the fact that we're leaving R in there and treating R like it's a number. We're solving for X and in terms of R. So we want to leave R in there and just treat it like it's a number. We cannot obviously simplify as far as we could if it was all numbers, because we could multiply things together and get one number. But we have to leave everything in terms of R. So I'm taking 3/4 R, quantity squared, which involves squaring 3/4 and R. 3 squared goes to 9, 4 squared goes to 16, R squared goes to R squared. I'm going to leave it like that, and R squared just stays R squared. I'm now going to subtract 9/16 from both sides. So then on this side over here, I actually have 1 minus 9/16. So on a calculator, clear all that out, 1 minus 9 divided by 16 will give you a fraction that I'm going to convert to 7/16. So it makes sense, right? So 16 over 16 minus 9 over 16 would be 7. 16 minus 9 is 7. Okay, so x squared is equal to 7 over 16 r squared. Now we want to solve this for x. If we look at our options, everything is just r, not r squared. We're going to take the square root of both sides, cancel out with the square on this side, and we're going to have the square root of this mess, 7/16 over r squared. Well, because there's no addition in here, you don't have to. If there was addition in here, it would complicate things, but there's not. So you can take the square root of each part. So we'll take the square root of 7, which is not a nice number. And if you notice, so if I do the square root of 7, you'll notice it's a decimal value. Notice none of these are decimal values, and you do see some square root of 7s in here. So that's actually a good sign. So I'm going to take the square root of 7, which stays the square root of 7. I'm going to take the square root of 16, which goes to 4. I'm going to take the square root of r squared, which goes to r. Okay, so that means B is our answer. But you'll notice if you get the square root of 7, well, if you just get that far and you're confused, or hopefully you can start eliminating stuff at some point as you're going through this problem. But remember, x is just half of the length that we're looking for. We want to double that. So the answer is actually D, and you got to be careful because they put B as an option, which is what they're trying to do is trick you there. B is not the answer. D is, because you got to double it. And so once I took the square root of everything, I had the square root of 7 over 4r, which is option B. But that's not the answer. That's only half the answer. We have to double that. So multiplying that by 2, 2 over 4 simplifies to 1 over 2, and we have root 7 over 2. Alright, I think that's enough for this week, or this video. I'm going to stop there and give you some more problems from the work packet. Hopefully this was helpful. Thank you, and good day.